Hi guys, I am Mushakwa Almtangeni with Maths XYZ, and today I'll be taking you through a lesson of financial mathematics in graphical format. In the previous lesson, I've already introduced you to financial mathematics of simple decay and growth, and also the reducing balance method, which is also known as the compound growth and decay. Alright, so today we'll just go straight into a question and see how to apply the simple growth and decay and also the reducing balance method into answering question when they are represented in graphs. Alright, here we have a graph which the y-intercept, the y-axis represent the value of items in rands, and the x-intercept represent the time in years. So the graph above represent an item which depreciate at 10% per annum. Remember, if you are here in this case, we are given the interest rate which is 10% calculated per annum, and we are told that this item which has been bought, it is depreciating over time. That means that in our equation then we'll be using a simple decay or a compound decay depending on which method we are going to use. Then it says one graph represent a straight line depreciation. That means that that is a simple decay method. And the other graph represent the reducing balance depreciation, which is the compound decay method. Then in these two graphs, that means one graph represent the straight line and the other one represent the reducing balance method. Then going to the question, the first question says, which graph represent the straight line method and motivate your answer. The straight line method is also known as the simple decay method. So that means that from these two graphs we have to choose which one represent the simple decay method. Remember, with a simple decay, it always represented by a straight line, as it already says by its name that it's a straight line. So from these two graphs we can just conclude that the black graph here, which we can name graph 1, represent the straight line method. And we also know that because it represents a straight line because it depreciates with the very same amount each and every year, unlike the compound or the reducing balance method where the depreciation is calculated from the previous year. So with this one we can now conclude that is graph 1, which represents the straight line method. Then the second question says, explain the difference between the two graphs. Alright, the difference between the two graphs, as you can see that from 100 up to from 100 value and going to the first year of after purchasing the goods, the graph was the same for both graph 1 and graph 2, of which I can just say for both the straight line method and the reducing balance. That's because that for the first year it's calculated on the previous year, which means that it's calculated for both reducing balance and the simple decay is calculated on the according to the first purchase which was made. Then going onwards here, then for the straight line it continued depreciating with the very same amount. But then going forward for the reducing balance method here, the value of depreciation is calculated according to the amount which was left from the previous year. That means that if the first purchase was 100 rands, for example, as we can see that the purchase was made by 100 rands, then for the reducing balance for the straight line method, as if they're saying that the depreciation it will be 5 rands every year, that means that every year it won't change, it will always be decreasing by 5 rands. But then when it comes to the reducing balance method, if from the first year it was 100 rand and the second time when it was depreciated by 5 rand, that means that we will now be left with 95 rands. Then 95, that's when they will apply the 10%. Each and every year they apply the 10% interest rate of reducing interest rate on the amount which was left from the previous years. So with the reducing balance, at the end of the day, your value, the depreciation value, it becomes less and less. But then with the straight line method, the decreasing value remains the same all these years. That's why when it comes to the straight line method, at the end of 10 years the value is worth 0 rands. But then with the reducing balance, the value is actually left with, it's still worth 40 rands after 10 years. So it's better to use the reducing balance compared to the straight line, since the straight line it does not calculate compared to the previous years, but it calculates comparing to the first purchase which was made. Then going to the next question here, it says determine the initial cost of the item. As we can see from the graph that both graphs start from 100, and then on the y-axis there is the value of item. That means that the value of the purchase, it was 100 rands. All right, then it says hence determine the equation of each graph in the form of A is equals to the answer. Then remember that with the reducing balance method, our equation is A is equals to P, which is the principal value, into 1 plus or minus I into an exponent of n, depending on whether it's decay or growth. If it's growth, then it's a plus. If it's a decay, it's a minus. But for this case, as we've already been told that it's actually depreciating over time, that means that our equation must have a minus instead of a positive. Then with the simple with the straight line depreciation, which is also called the simple decay method, then the equation is A is equals to P into 1 minus IN, because it's depreciating. Then with us, starting with the first graph, which we can say it's graph 1. Starting with graph 1, remember our standard equation for the simple decay is P into 1 minus IN, close brackets. Then the first purchase, which is the principal value, here it was 100 rands, then we'll have 100 there into 1 minus our interest rate, in this case is 10%. That means that we have 0.01, and our n, we don't know how many years it will be, depending on how many years the person will be calculating. For this case, the value only lasted for 10 years, but then we can't put 10 years here because it's an equation. We must have one unknown in the equation, which is our n. Then going to the next graph, which is graph 2, of which graph 2 is for the compound decay. It's A is equals to, our standard equation is A is equals to P into 1 minus I to the exponent of n. Then here we know that our principal, or our initial amount, it was 100 rand, into 1 minus our interest rate I is equals to 10%, of which 10 divided by 100, it will actually give us 0.01. Then here we'll have 100 into 1 minus 0.01 to the exponent of n. Then these two are the equation for this graph. The first equation is for graph A, which is the straight line method, and for the second equation is for graph B. We can always say that that's graph B, this one, which is for the reducing balance method. Alright guys, I hope you guys understood this one. Actually, I made a mistake here. It's actually 0.1. 10 divided by 100, it will actually give us 0.1. So here it's not 0.01, it's actually 0.1 n. Then that's it for this question. I hope you guys understood that when you are answering question on straight line and also the reducing balance method, the difference is for the straight line, it depreciate with the very same amount all these years, but then with the reducing balance, the depreciation value becomes less each and every year because of the because the depreciation or the interest rate is applied on the previous years, not compared to the original amount which was used to purchase the goods that you have bought. Then I hope you guys understood this question. Let's just move on to the next question, of which the next question here, it says the value of water in a steam ion decreases by 18.5%. So we already know that that's our interest rate. In this case, we are talking about water, so it can't be interest rate, but we know that is the rate that this water will be decreasing in the ion. Then per minute that is in use. If the ion has been used for 6 minutes, so this is the period or time, which is n, and there's 29.31 millimeter of water remaining in the ion. Determine how many millimeter of water the ion had initially had. So in this case here, we know that we have to use the equation A is equals to P, which is our initial value, 1 minus I to the exponent of n. Reason being, we know that it's decreasing, so that means that we have to use the compound decay method, because the water will be decreasing. In this question here, we are actually given the final amount, which is 29.31. We are also given the decreasing rate, which is 18.5%, and we're given duration, which is time, which is 6 minutes. What we're looking for is P, which is our initial amount of water which was inside the ion. So let's see how we're going to calculate that. It will be A is equals to, we already have A, so what we're looking for is P. So making P the subject to the formula, we'll have 1 minus I to the exponent of n is equals to P. Then we'll just substitute everything that we have, and there we'll have our answer. Our A in this case is 29.31 millimeter, divided by 1 minus I, which is 18.5. Remember, I told you guys that you must divide by 100, and then our duration is equals to 6 minutes. Then from here, we'll just use a calculator and see how much we'll have for this case here. Then here, with 29.31 divided by 18.5 divided by 100 into an exponent of n, which is 6, then we'll have 29.31 divided by 1 minus 18.5% to an exponent of 6. Then here we're gonna have 100.02 millimeter. Then now that we have 100.02 millimeter, we know that the iron initially had 100 millimeter inside the iron had 100 millimeter. Then it reduced with 18.5 for 6 minutes. Then it was only left with 29.31. Alright guys, I hope you also understood this question, that financial mathematics can also be used when you are just calculating anything that will be depreciating or appreciating, regardless of whether it is money or investment, or even for this case we were talking about water. Alright guys, I hope you understood this lesson, and if you didn't, please put it on a comment note, and then we'll have a follow-up on it. If you haven't subscribed to Maths XYZ on YouTube, please do so that you will get notification when we upload videos. Thank you.